Hey, welcome back to the bench. Good to see you again. Thanks for joining. Hope you're all well. Today on the bench I got a Harman Kardon 580i. It's an HK 580i. Sorry. Dual synthesized quartz lock stereo receiver. I love these era of receivers. They have a lot of value for us today because these were built to sound really good, and they do sound really good if they're all tuned up and running properly. They're compact too. They're not overly large, and they're nice. I like the size of them. I like the silver face, obviously. I like that. And this one's got a lot of problems. So this is one of my eBay finds. Let's have a look at what the eBay seller wrote. Vintage Harman Kardon stereo, HK 580i for part. Missing a foot. Yeah, that's correct. It is missing a foot back there. Power button is broken. Yeah, the button has busted off of the shaft. It still works, but it's really iffy. Okay, missing a knob. Yeah, the bass knob's missing. An AM antenna is broken. Well, it's ripped off actually. There is no AM bar antenna on the back. The cover's been repainted. Okay, well, it doesn't look bad. It's kind of gritty feeling, but it looks good. A little dirty, but whoever did it did not too bad. Some scratches on top of the faceplate. Yes, there's a dent here. I might have done that. I don't know. It looks like it's really sharp here. And other than that, the face is pretty clean. Aside from a missing knob and dirt. Missing rubber grommet on the power cord at back. Power's on but does not work. Seems to have DC on the right side, not to be connected to speakers like it is now. Yeah, for parts only. So I did connect this to power, and I was listening to it. It does have one active channel. The other channel's completely dead. So let's turn this around. So, yeah, there's a grommet missing, a strain relief, actually. And I don't know if somebody replaced this power cord. It looks like they might have replaced it. We'll get into that. We'll see about that. 2 sets of speaker outputs, 2 courtesy outlets, completely ripped off, missing bar antenna. I don't know how I'm going to replace that. It's actually broken too, the plastic mount for it. Inputs for your AM FM tuner, muting adjust, and then there's a switch here for AM tuning scale. You can adjust in 10 kilohertz increments or 9 kilohertz increments, depending on which way the switch is flipped. Phono, auxiliary, and 2 tape loops. And like I said, it is missing 1 foot here, which is not a big deal. I think I can scavenge something off of another receiver. Let's have a look inside. All right. You can pull off the lid. I had the lid off earlier and the screws are removed. I've got a little bit of rust staining here. I don't know. Overall, looks pretty good. Here's a bag with some screws and some fuses. Okay, that's me. So, big power transformer in the corner. We have dual filtering for our channels. Big heatsink in the middle. Very dirty. It's quite dirty, and yeah, it's quite the mess. And from looking at this, it's going to need a lot of cleaning. Probably going to need a full recap. I'm probably going to do that. Typically when these old HK receivers come in, I just fully recap them because they're pretty much at the end of their life. Let's spin this around. See the power switch, it's broken at the connection here. I gotta fix that. Speaker switches are okay. I have a little power supply board here. It's very dirty. I got a couple blown fuses, I think. Because I did replace some fuses, and I think one channel heats up. Let me see here. I wrote some notes from when I was testing it. Okay, we got a rumble from the phono stage. So there's something going on in the phono stage that is either... let's have a look at it. Okay, we got a rumble from the phono stage. And it could be a number of things. It could be a bad transistor, bad cap. It could be the conductive glue that's leaking current. It could be something maybe in the power supply that's causing the phono amplifier to make that rumble noise. But we'll get into that. We'll completely redo this and clean it up. Okay, we got no left channel. Left channel's dead. And transistors are available from the bottom. I'll take the bottom off and we can check if we have any shorted transistors, output devices. It's got the missing foot. Broken power switch, we already talked about that. No AM bar antenna, I talked about that too. Heavy distortion in the right channel in the power amp. Now, I was listening to this and it sounded okay, but the right channel, heavy distortion. I think it might be something to the effect of maybe a dirty speaker switch, or these circuit breakers here have silver contacts in them. They might be oxidized and might be having a problem passing a signal. So I think it's something to do with that. I think the amplifier is working fine, except when the signal leaves the amplifier, I think there's something blocking it, and that's what's causing my heavy distortion right channel. AM FM tuners work both good. I'll be checking all the caps. Some of these caps look dead already. I can tell just from looking at them. They look all dried up and cooked. So I think the best thing for this is just fully recap. Missing a bass knob, of course, we saw that, and dirty switches, dirty pots, and just an observation, one of the channels is running really hot. I can't remember which one it was, but we have a biasing problem for that one channel. Maybe it's a dead channel, I don't know. I also see something else that's going to probably need attention here. Is there's a NiCad battery back here, and this is probably dead. This is for memory backup for the FM stations, so we'll replace that as well. And everything else is just filthy and dirty and needs cleaning. So let me pull the bottom off. Let's have a look at it. Okay, that actually wasn't very easy because some of these screws were, I think they were cross-threaded or over-tightened or something. And I really had to fight to get them out. So, no water staining here, just dust. And what is going on here? Oh my God. Got lots of scary looking stuff going on here. Lots of circuit glue. Is this factory the way they put these wires in here? And capacitors? Must be. Unbelievable. Looks like somebody tried reworking this area. It's all scratched up and dirty, filthy with flux. Somebody was resoldering back here. Oh boy. Okay. Let's check some of these output devices. Where is it here? That one's okay. That one's okay. That one's reading weird. It's reading open. Okay. Okay, that's all good. The NPNs are all fine. And the PMPs seem fine too. So maybe we're going to get lucky here. Maybe the output for devices are good. That's what I'm hoping. Look at this. Let me get the camera. You can see that circuit glue is all dried up. I don't see any corrosion yet. But it's definitely, this stuff is definitely conductive. Okay. See how crusty it is? I have to clean all this off. Which is what I do anyway, so it doesn't really matter. Wow. Yeah, it's going to be a... These are diodes in here. I wonder if there's a better way to do that. Gluing them down like that. Look at this. It looks like rust, but it's actually the glue. Wow. Okay, now look at this. This is a little power supply corner back here. It looks like somebody's been scratching at it. I can see a crack here, crack here. See cracks already. I don't have to look very hard. Yeah, wow. Okay. Yeah, so it looks like I got my work cut out for me. First steps, I think I'm going to rebuild this power supply first and make sure this is 100% before I do anything. I know it's working. I have AM/FM tuners working, so this is probably working too, and the phono stage is working. So we're getting voltages out of our power supply, but I want to make sure that it's 100% before we continue on. So let's fix the power supply first. I'll probably just go through and recap it. There's 4 or 5 caps there, and then I'll focus my attention on the one channel that's dead, and we'll get that going. Yeah, you can see here this power cord has been cut and spliced. Ouch! Something stabbing me. Cut and spliced on here. It's not a very good job. It's not even. So I'll rework this. So I don't know. This cord's probably too short now. Looks like it's too short. It's not very long. It is probably about 4 feet long. So I'll put a new power cord on and we'll fix that up. I'm just going to clean this up because I can't even see the solder connections with all that brown guck on there. I'm just going to give this a good scrub. See if we can clean this up and have a good inspection on it. I can see a couple cracks in here already. There's some cracks here on these pins that are for the wire wrap. Okay. That again. Use another. Somebody replaced a transistor or something, and the legs are quite long. Looks like they're, I don't know if it's bridged or not. It's going to need a lot of cleaning. Yeah, like I got that one's cracked. I think that one's cracked. This is almost shorted here. This one's cracked. This one's cracked. This one's cracked. Yeah, it's a mess. Yeah, here's a look at the power supply board I yanked out. It's pretty filthy, and it's got all the circuit glue everywhere. Have to clean this up somehow, I don't know. And then the first cap I pull out is a 2200 at 25 volt. This measures at 1600 microfarads, not 22, so this was garbage. And I expect these other caps will be the same. There's 4 more here. So I'm just going to go through and do some cleaning and recapping. This Harman Kardon board here is not marked for polarity on the caps, so you got to pay attention which way the caps come out. Wow, is this ever dirty? I'd like to remove this board and then I could just wash the whole thing, but it's got so many wires going to it. I'll do it and I'll just leave it here and clean it here. Got some bad fuses too. That one's bad. That one's bad. Two bad fuses, 3.15 amp. Yeah, I was just scraping away here and I already found some bad stuff. Let's see here. We have, you can see this little diode down here. I was scraping this crud away, and the one lead of this diode is completely eaten away and disconnected. And the other side is ready to, if I wiggle it a few more times, it'll just fall right off. So I'll have to replace that diode. Okay, here's a look at the circuit and the power supply for that diode that I found broken. It is D58. It is a 30 volt Zener. And this is kind of a weird design. I've never seen anything like this before. They're tapping off one of the secondaries off the main transformer. And this should be, well, after it's rectified and filtered, it's plus and minus 39 volts here. So I took a tap off here. It goes up and around through a 180 ohm resistor, a 100 ohm resistor, and through a 47 microfarad cap. That's really odd. And then it looks like it's got this, looks like a voltage doubler circuit here, and then it goes through a 1K resistor, and then it regulated down to 29.5 volts with a Zener, and it goes off to pin 10 out. Let's look where pin 10 goes. I've never seen them feeding power through a cap like that. I don't know if that's really good practice. Let's look at the other side of that circuit. Okay, pin 10 comes from pin 10. It goes into this weird arrangement. We got a 2SK163 that's used as a, I don't know what that's used as. 29.5 volts going in there, 28.5, so they're using it as a 1 volt drop. I don't understand what the purpose of that is. And then they have another Zener here, is 27 volt diode, cap, resistor, I don't know, 47 ohms. Okay, so this is, I don't even know what they're doing here. I think this is some bias voltages for the fluorescent display. That's what I think this is. If I look at the previous sheet, let's go back. There's a little transformer here on the board, T51, and that takes AC from the secondary here. This is a 6 or 8 volt feed from the transformer. It goes up to this transformer, and I think it steps it up. It's probably a higher voltage AC, or maybe it steps it down, I'm not sure. But this is probably for the filament, and then they apply a bias voltage here. Got a 24 volt Zener capacitor, and it's biased to minus 24 volts. So I think that's what's going on there. But we'll replace this Zener diode and all these caps, and then we'll get this back on the road. Okay, so I finished working on this power supply board. You can't really see it. It's buried under this wiring harness. and I tried my best to clean it up just with a Q-tip and alcohol. Can't do much for it. I didn't want to remove it. If I could remove the board, I would take that transformer off, and then I would wash the board with soapy water and then dry it, put the transformer back on, and I would go that way. But since I don't want to disconnect 25 wires here, I'll just leave it alone. It's going to look kind of dirty, but whatever. So that's finished. So now we're going to move on to the main power supply. So I removed the 4 filter caps, testing them out. And here, I'll put you up on the machine so you can see yourself. Okay, here's one. This one comes back at 3,850 or so. So that one's shot. Next one shows up at around 4,300, which is pretty good. So that one's the good one out of the bunch. And this one's at 39.3. That's a bad one. The last one here I think is a little higher. Yeah, 4,100. So yeah, they're all going to get replaced so that they're all equal and balanced. Here's a new one. 6,300. It's pretty good. So what I'm going to do is replace these 4700s with 6800s for brand new ones, and same size. Just a nice upgrade. As soon as you take off the faceplate, you're going to find it's connected with one connector and 2 LEDs. You just got to unclip the LEDs and they'll pop out, and the connector pulls straight out. But once you get your faceplate off, I recommend just pulling out the vacuum fluorescent display. It's just in a socket. Just carefully pull it out and put it someplace safe so it doesn't get damaged while you're working on it. Okay, so I was doing that I was working on the power supply board, and I was thinking to myself, which direction I want to take this. Do I want to take the video on the direction of troubleshooting the power amplifier, or do I just want to bypass all that and just rebuild it? And I was thinking what would be best for the video itself, but I was looking at this, and have a look at this. I started scraping away at the glue. Look at all the corrosion here I'm dealing with. So no wonder this thing doesn't work. Or one channel anyways. I got corrosion everywhere. I got heavy damage to the board. And it's going to be a while scraping this off and repairing this. And I have a feeling I'm going to find some broken traces too, because the traces are corroded. If I can And I've also tried different solvents to try and get this glue to kind of lift up, but alcohol and a few others haven't seemed to do anything. So I'm just going to pick away at this, and these diodes, they're back to back. One's a Zener, one's a regular diode. I was looking at this on the schematics, and it's these pairs here that are these ones. And I was thinking, could I just remove these and do something better than this? I could maybe do something surface mount. And it's a 6.2 volt Zener. Where is it written here? Oh yeah, right here, 6.2 volt Zener. So I'm going to work at this, pick away at it, and see what I can do for cleaning this up. This here, I think, is a little capacitor. It's all tuned in heat shrink. Wow, look at this freaking mess. And Harman Kardon did this to themselves here. Look at this. This isn't operator error at all. So, here's that side. And then there's this side, same thing. Yeah, I'm going to do something different here, I think. And then once I fix this all up, then we can see if the amplifier is working or if we need to troubleshoot there and later. But I have a feeling this is the source of our problems. Another thing I'm considering is these transistor clusters. There's a cluster here, and they all share this metal heatsink. I wanted to take these all apart and re-grease these because the heatsink compound on these is all dried up and it's all turned to dust. So I think these are gonna come out as well. And since I'm taking these out, I might as well rework the back side of the board and get everything 100% before I reassemble everything. So I think I'm just gonna rip most of this all apart and just rebuild it. And that should solve our problem with that one dead channel. Hopefully. We'll see. But I think this needs to be addressed as well. All of this. You can see here on the other side as well. You can see I got two here, one under this and one here. Remove those as well. And they all need to be reworked. Relocated the diodes to where they need to be, here and here, and set them up. I'm going to anchor these down better and then ran a wire back to where it come from to clean up that mess and tidy it up. Replace the cap, reuse this cap, took out these two clusters of transistors, cleaned them, tested them, heat sinked them, and put them all back together, just reinstalled them. Everything's good on this channel. Now, and then I actually coated the bare copper with UV solder mask, UV activated solder mask, and I cleaned that all up and covered those up. So this channel should be okay to go. Everything's recapped and working. So now I have to address my attention to that mess and spend another day cleaning this up. This one's not as bad though, I don't think. I already cleaned up a lot of the mess already by just picking at it. There's some traces here that are exposed, and yeah, thankfully there's no corrosion here, no serious corrosion, but it was definitely enough probably to keep the channel from working properly. So see, here's some bare copper I need to fix up, so I'll get on that. Another thing I was doing is I was repasting the output transistors. I got these two done, and I still need to do these two. The heatsink compound is pretty much dried up powder by now. It's yeah, it's not any good anymore. So I'm going to take these two out and clean them, and then that's pretty much it for this. And then we'll go and maybe we can test it to see if it's all working fine. Okay, as far as I can tell, it's complete. I got the 4 output devices replastered with new heatsink compound. The old stuff was all dried up and caked, I got both channels reworked. This side went a lot, no, which side was it now? Yeah, this side went a lot easier than this side did because there was less going on here. And I got it cleaned up, got it put back together. And you can show you this. Here's the top, look at the top of the board. It's not the prettiest thing on the planet, but it's going to work. 401, 402. Yeah, so I think this is going to perform okay. I didn't find any faults. I did find a couple of resistors that were cooked. You can see them here, they're cooked. And surprisingly, they're still holding their value. But I replaced these anyways with 1 watts because it looks like they're getting a little overheated. So this is all back together. Next step is I need to install the 4 filter capacitors, and then we can move on to testing. And we'll see if the amplifiers are working. If they are, it's great. If they're not, we'll troubleshoot and figure it out before we move on to the rest of this. There's a lot of work on the rest of this. I got all kinds of switchboards, and you name it. So there's a lot of work to be done on this receiver. This is not a simple job, that's for sure. So let me put those caps in, and then we'll get back to you. One thing I need to do before I power up is replace this cord. I just hacked it off because it was just dragging and being in the way, so I took it out. Let's see. Do you think it's soldered? No, it's not. Look at that. It's just twisted together. That's a double no-no. You have no strain relief and no solder, so that's bad. But it's just temporary. It's coming out. Okay. Now this here, we have to figure out. Let's pull this all off. This is my original cord. One of the wires goes here, I believe. Maybe I'm wrong. No, they go to the other one. Let me try taking the other one out. Little tabs here you press on the side. That's what locks it into the chassis. So you just press on the little tab and give it a little forward push or backwards push, and out it comes. And then you do the top as well. If you can get in here. There we go. So what I could do is I could pull this all out if there's enough wire length. Oh boy. Okay. Okay, I see it. Here's the cord. It's fighting me. It's pretty tight quarters too. There we go. All right. Now, I can work on it outside. So feed the cord in, out this hole. I can probably heat shrink these. Let's cut this one off. Don't cut your finger though. Here's one. Okay. It's going to be tight, but we can do it. Okay. So, let's remove this. Pull this out. Okay. Okay, let's pull this one out too. Oops. Okay, perfect. Throw this in the garbage. Okay, I'm trying to pull this out, but it's not coming. It's got a resistor attached here. That 3.3 meg resistor is attached to the chassis. Just desolder it. I wonder. We'll just desolder it for now. We'll put this back when we're done. If I can get enough heat on it, we can pull it off. There we go. Now I should be able to pull this out. There we go. The reason I want to pull it out is because I want to be able to put heat shrink on these. So here's my new cord, replacement cord. I'm going to feed it in the back. And then feed it out the hole. See if I can do this. There's one wire, 2 wires, okay. There we go. So let's strip these. Okay. The wire with the ribs is your neutral, and that is going to go to this one here. Actually, this let's put this on first. No, we need a heat shrink. Hang on. Okay, let's try this again. This time I got a little bigger piece of heat shrink. So we're going after the neutral right now. And this one is going to be put on the side. Let's see here. I don't know if you can see this. So our plug originally was non-polarized, and we're putting a polarized plug in. So what we're going to do is we're going to make the switch side and the fuse side are hot, and we're going to put our neutral on the unfused and unswitched side. That's the way it should be on any modern piece of equipment. So let's get back to this. I got heat shrink here, and we're going to put our neutral through here. Should be room for all three. The problem with the heat shrink is it makes it difficult. Okay. I gotta clean these up. Let me clean this. I gotta clean this lug up here and get the solder out of it. No. Okay. Let's put our wires through here. And I want to wrap it around the lug best we can with the length that we provided ourselves. Okay, I think you can. So there's that connection. Let's solder it right now, because if we don't solder, it's just going to fall off when we work on the other side. So let's solder this. Now the trick is you don't use too much heat, because if you get too much heat on it, your heat shrink is going to shrink on you, and then you won't be able to slide it forward. So you got to do this kind of quick. And let's see here. Okay. And blow on it. Let it cool. And then we can slide our heat shrink up on it. Leave that for now. Okay, let's do our other one. This out of here. This here is our other one. So this is the unswitched outlet, and then the line cord goes directly to it. This is the switched outlet, and this is what comes back after the power switch. So that's the difference between the two. And you want to make sure that you have your connections on the unswitched one. Okay, let's feed this heat shrink on. Okay, pull that back. Okay, we are ready for this. Let's hook this one up first. Bend it. And then hook this one up. Okay, bend that. Okay. Takes a lot of heat. I'm using 16 gauge copper here. It's a 16 gauge power cord. So, got plenty of power. It's not going to get all wimpy on us. Okay, slide this heat shrink up. Actually, I need to address this better. Alright, so we're heat shrinked and we're ready to one thing I like about the Harman Kardons is they on all the mains wiring they insulate everything with heat shrink tubing, and they don't leave exposed wires like I've seen on Sensui and other ones where you can touch and you can get electrocuted. That's why I like Harman Kardons. They take the time to protect us. Okay, so let's shovel this back in. Our resistor, I'm going to break that off. A little tight back here with the wiring. Okay. There we go. Let's shove this one in. Let's shove this one in. And then connect the resistor back up if I can find it. Can't see it. There it is. The resistor's kind of short. Can unwrap it. Okay, wrap this back up. Okay, solder this. It doesn't want to take solder. Solder to the steel chassis. It doesn't want to. Wow. Let's try scraping it. Maybe the thought of solder will stick after I scrape it. How the hell am I going to solder to that? It doesn't want to take. Okay, next is a strain relief. Hope this one fits. It should. It looks like it will. There we go. Good stuff. Alright, let's try this again. Scraped it down several times. It should stick. Just got to put enough heat to it. Doesn't want to take. Drop some solder in there. Okay, I can't get solder to stick to this metal. It's steel. I think it's galvanized coating, but I think the galvanizing's gone. I don't know if I can solder to galvanize. I think you can. It doesn't want to accept solder whatsoever. So what my solution is, I'm just going to put an eyelet underneath this transformer mount and solder it to that, because it does have to be connected to chassis, this 3.3 meg. Let me solder this up right now, and then we'll get that connected. Oh, don't do stupid stuff. Okay, wants to play games here. Try this again. Okay, isn't that cool? And that'll be my ground connection for that resistor. Okay, I'm going to reinstall the 4 fuses for the power amplifiers. And I think there's a bulletin, a service bulletin for this receiver. These are 3.15 amp, and I think the service bulletin says replace them with 4 amp. So I'm going to go back and read that again. But got our fuses in. There's our power buttons off. Let's plug this in and try our first power up. I think we're ready to go. Let's try it. Going live. No pop fuses, no DC, a little bit of DC on the one channel. We're consuming 80 watts and climbing. That's not cool. I'll shut this off. Don't know where that power is going. I don't feel any heat from those transistors. Don't feel any heat on the emitter resistors either. 80 watts is quite a bit. Okay, let's set to zero balance, and let's turn this back on. It's 22 watts. Okay, then it jumps up to 75. Okay, so we have on the left channel, it's drifting a lot. $88 watts climbing. 89. Let's see where this heat's going. Got our output devices are just barely warm. Okay, let's do the other channel. I'm pretty sure I don't have the bias set correctly. Okay, doing the other channel. Turning it on. Okay, we're at 0. We're still consuming 90 watts though. That's not cool. I don't know where this power is going. Doesn't seem to be. Oh well. I don't know if you can see this. I'll turn this meter up so you can see it. When I turn it on, it goes to about 22 watts. And then once the amplifiers kick in, it jumps way higher and goes up to 80. But look what we have for bias here. We got 130 milliwatts or millivolts. Let's turn this down. Oops, wrong way. And our target is 33 millivolts. I'll leave it at that for now. Then we drop to 66. Look at the other channel. I have a feeling the amplifier is working good. It just needed adjustment. You know, yeah, here we got the same thing. So let's turn this one down to 33 millivolts. Okay, 30 for now. And we're still consuming 42 watts, 43 watts. Seems high. But should be better now. I'll let this temperature stabilize and then I'll do it again and we'll get it bang on. Okay, now we got the power amp finished. Let's do a test on it, make sure we're all good. I went back and touched up those 4 adjustments one more time and peaked them, and they're all good now. So we have 1000 hertz tone. We have a scope, both channels, 8 ohm load. I'm going to turn this thing on and wait for it to kick in. If I could plug it in first, it might work. Okay, here we go. Sits at 22 watts, 21, and then once the power amplifiers kick on, it goes up to about 45. Okay, so are we on auxiliary right now? No, we're not. I have to figure out what auxiliary is on this thing. Yeah, we're getting something out of one of the channels. Something weird is going on here. Okay, I got this all hooked up to do a power test, just to see if the amplifier is working. And let's try it out. I got the volume turned down. I'm on auxiliary. And let's see here. Let's put the speakers on first. It's here are speakers. Turn those off. And it looks like we have a signal on the left. If I keep turning it up, the right channel is doing some severe clipping. And it's got a low amplitude. But if I turn up the left channel, let's see here, where am I at? Volts AC, let's see if we can get this. See, then we get a weird distortion. And I'm at 12.6 volts RMS, and then it clicks off. And then I think it times out and comes back. Yep, there it is. Goes off. So that'll keep going forever if I leave it like that. Now, look at this. We're not at full power yet, but we're getting a distortion, a bad distortion on the bottom. So that leads me to believe we still got problems. Okay, let's look at the right channel. Set up our triggering for the right. Okay. So I've got the right channel on 500 millivolts, where the left was on 10 volts per division. So there's a big difference here in sensitivity. So I turn up the right channel, and it's weak, it's distorted, it's getting clipped. If I turn it full blast, it seems to fade away after a while. Right there, it just fades away. So we still got problems in both channels. Okay, I've been poking around this amplifier. Actually, what I did is I pulled the fuses for the left amplifier, and I have left the fuses for the right amplifier. I'm doing one at a time here, just to keep and I'm taking voltage measurements and checking resistors. Everything's normal. Everything, can't find anything wrong. Everything looks normal. Checking voltages, everything looks good. And then I got to thinking, you know, that amplifier balanced up properly and biased up properly, so it's probably working fine. And then I got thinking, why aren't we getting a signal through here? And I'm looking at this. They got these two circuit breakers. You got your emitter resistors, circuit breakers, and then it goes to your speaker switch, right? Well, let me check these circuit breakers, because something's suspicious here. So let's see. Can you see that? Okay, there's one right here. That's measuring 0. This one. Oh, look at this. 150 ohms, So that circuit breaker is bad. That's why we got one dead channel. And that would make sense. But the left channel was cutting in and out. So maybe these are both bad. So let's rehook our equipment up to the speaker outputs of the amplifier, not through all this junk, and then we'll see if it works properly or not. Okay, what I've done is just did some bypass wires on the circuit breakers, just temporary, just for testing. Alright, let's try this one more time. This time we have the both circuit breakers bypassed so that we're not going to get any weird results here. So let's turn this on. Let's get our meter out. Turn this on. And it goes up, shoots up, and then it settles down at 22 watts. And then the power amplifiers kick on. It's consuming about 40 right now. It's going to warm up 36, 37. It's going to go climb up. Let's see what we have here. We have both speakers turned on. Okay. So we have what looks like signal both channels. Left and right. Okay, let's shut the speakers off. Trigger off channel 1. Okay, let's go. Okay, here's our left and right channel. We've got signal on both. And I'm only doing about 10 watts right now. Let's take but they both seem to have the same fault. It's almost like the one power supply is not providing. Alright, I think I've been led down a rabbit hole again on the second time. I should know better, but here, this is what I found just now. Scoping the input, I believe this is right channel. You see how that looks? So we got a problem in the preamplifier section, and it looks like our amplifiers are working good. I'm not going to spend any more time on this power amplifier because I think it's working. But everything here is working, everything here is working. We got a problem here, and I think it's probably a power supply problem. If I check, I'm probably missing the negative voltage for this. And we could do that right now because I think the wires are right here. Let's check this. Let's have a look. But I did go through the power supply, and I didn't check the outputs, but I did go through it and make sure everything was fine. Okay, positive right here. What do we got? 17.6. Negative. What do we got? -5. Okay, we got a problem with our negative supply voltage. Alright, the little voltage regulator supply here is down here on this board, and I did replace these caps, but I didn't do anything else here. And there's two Zener diodes. If I check one, let's see, one side that's grounded, and if I check the other diode, that's grounded. Okay, but if I check the other side of the diode, got 19 volts, and this diode here, 6.5. So that's my problem. Probably got a bad Zener here that is throwing a bad voltage out onto the rails for the preamplifier. So my problem is located right here, and I'm going to go through and check these transistors as well, because I don't know, one of them's bad. One Zener is definitely bad. I think it's diode 15, D15. It's supposed to be 24 volts. And this one's supposed to be 24 volts too, I think. Oh, hang on. This is 19. It's not marked here on the board what diode number this is. It's marked on the board as resistors, R15, R16, but there's diodes in the place. 15 and 16 are supposed to be 24 volt Zehners, and they're not. Here's another couple more. Let's see, this one here's marked diode 15. Okay, that's 0 volts. 24, okay, that's making sense. Let's check this side. 0 volts. Minus 23. So those two diodes are fine. It's these two in the middle, and they are diode 18 and diode 19. 18 and 19. And I think 18 is defective. Let me try replacing that diode. It is supposed to be 20 volts. Okay, I searched through my stash. I don't have any 20 volt Zehners, but I do have some 18s. So I think I'm going to just substitute an 18 in temporarily until I can get a chance to order some proper ones. And we'll just put this one in and see if it brings back our clean audio. I have a feeling it will. Okay, our new Zehner's in, so it should be Zehnering properly. Is that a word, Zehnering? I don't know. Okay, turned on. No, we're not turned on. Turn this on. There we go. So this one here should be minus 22. This one here is plus 23. Okay, we're a little bit out of balance because I don't have the right Zehner in here. Let's see, I got ground, ground. This is the positive Zehner. 18.9. This is a negative Zehner. Ah, look at that. So we got a bad transistor in here. I thought it was a Zehner. Okay, hope you can see that. All right, so D18 was the suspect. It was only Zehnering at 6.5 volts, which I thought was wrong, so I replaced it, and it no change, right? So I pull out Q7, test it, it's fine. Pull out Q5, test it, it's fine. So I'm going, what's going on here that is causing a problem? So I start checking some resistors, 247s here, they both test okay. I check its partner in the negative supply, R13, and it's open. Okay, so this line comes from this power supply here that you can, where is it? Yeah, right here. These two lines go up. So I'm going to replace these two resistors. I hope that's the problem. It should be the problem. I think this thing has just been cooked too long, and I think it just gave out. So unless we have another fault, which is possible, we could have a heavy load on one of these regulated lines, which could be causing excessive current draw on these, which would cause overheating. All right, so what I did is I replaced R13. That was the one that was open. The other one I checked, it's good. I put the two transistors back in. I removed my replacement Zehner and put back the original Zehner because I don't have any reason to suspect it's bad now. Let's power up. And if we blow that resistor one more time, then we got a problem. We got a heavy load somewhere that's drawing too much current. So I got it plugged in. Let's turn it on and check. And it looks like everything's working. Consuming 25 watts. And it's jumping up to 40. I think that resistor's holding. 25 watts now sounds like a better. Let's check our voltages. is it again? I think it's this blue one, minus 23, and this red one. No, it's this red one, plus 23. So we should have our voltages back on our preamp. Let's check back here. Back here we had 5 volts. Okay, this one's first. This is a positive. Plus 15. Negative. Minus 15. Okay, I think we're good now. Let's do a power test. Alright, for the last time today, we're all wired in for a power test. Got 1000 hertz tone being fed in. Scope's hooked up. You should be able to see it on your screen. I have an 8 ohm dummy load for both channels, and my power meter here. I don't know if you can read that. Let's turn it on. We got our balance control set to the center. Yes, okay. Let's turn it on. Jumps up to 25 watts now. Now that that power supply is working, we're drawing another 2 more watts, and then it jumps up. And it's going to stabilize around 45 or so. Let's see here, we got both our channels, and they both look normal, except one is really quieter than the other. Okay, our right channel goes into clipping way before the left, so we do have an imbalance. And I think that imbalance is in the preamplifier. I'm going to check that though. Let's turn down the balance so that we're not freaking out the right channel all the time. So let's get this to peak out at clipping. Right about there somewhere. Turn this down a little more, just so it's out of clipping. Okay, and we have 22.93 volts RMS. I'll let this cook for a while. We're drawing 250 watts. So from that alone you can calculate how much is going out to the speakers, how much is being burned up in heat. Let this go for a while, let it cook. Happy to see an amplifier working now. That's the problem when you get assumptions. You make an assumption, oh yeah, it's got to be this or that, and then you start looking for it, but you overlook something else. That amplifier was working all along, but it threw me because the bad signal was going through it, and it looked bad. So uh-oh, we have a problem. What happened there? Our left channel is wigging out right now. I don't know if you can see it, but it's kind of going up and down in amplitude a little bit. I think it's kind of let's see here. And the right channel's moving too. This is getting quite hot here. We've been doing this for 5 minutes, continuous full power. This is quite hot. The load and our heatsink is getting quite hot too. So I'm going to turn this down a little bit. I just don't want to turn the power off yet. I want it to heat up some more, because if we've got a heat related fault here, I want it to come out now. And we're just going to let it cook for a while longer. There it goes. It's starting to twig again. If you look at the top trace, the left channel, it's kind of dropping in amplitude at random, like it's trying, but it's not quite there. It's like it's got a bad connection, or it's losing something. Maybe it's a bad switch here, I don't know. Could be a bad switch. I haven't tested any. Yeah, see, look at this. Okay, that's a big problem there. Yeah, see, look at we getting. Yeah, we definitely need some cleaning of the switches here. So the more I play with it, it should be getting better, not worse. Okay, that's for another day. Yeah, look at that. It's terrible. That's the function switch. That's the one that's buried the deepest. Okay, we are at probably 8 minutes now. 8 or 9 minutes, full power. I'm shutting it down. I think it's proved its point. The amplifier is working good. It's quite warm, but it worked flawlessly. We still have other problems to deal with, but we'll get to that. And what I'm going to do is I'm going to end this video right here, because this took a lot longer than I expected, and I still have a lot to do. I still have quite a bit. I have to pretty much disassemble the whole front panel and go after all these switches that are buried. There's 3 layers of boards here, and then there's a board back here. That's the one that's causing the problems right now. And there's the tuner in itself is all digital. For the digital display portion, I have to go through all that, and the tuner itself, I still have a lot to do, so it's going to fill up another episode here for sure. So I'm just going to leave this at now, and call her quits for the day. Unplug everything, let it cool down. So I'm happy I got that working, but we still got a long ways to go. All right, thanks for watching. Take care, and we'll see you on the next one.